Hi guys, we're going to have a look at the reverse product rule today. Some people call it integration by parts, but I don't like that title much. I use the uv dash, integral of uv dash equals uv minus integral of u dash v, and that really means there's a dx there. We don't really need to write the dx for the memory, just to remember it. And other people write it as integral of u to v equals uv minus v du. I found that people who use this, students often get confused on how to use this, and it's a bit clunky. This seems to be much more efficient, and that's how I'm going to do it, okay? All right, just a proof. It's called the reverse product rule because it's related to the product rule in differentiation, which is this one. If you differentiate uv with respect to x, assuming u and v are functions of x, then it's uv dash plus vu dash. Integrate both sides. This one cancels out, of course, because you're differentiating, then you're integrating. And you have your formula right there, easy peasy. Now I'm going to do all these examples, 6 examples, various different types of formats. The last two are a little more unusual. These are more straightforward. Integral of x dx. Write the formula down. I equate the left-hand side there with this one and think, well, what could u be? You've got to make a good choice, a wise choice of u. If it doesn't work the first time, try something else. So in this case, u equals x, u dash is 1, v dash is the other one, ex, and therefore v must be ex. So remember, if you differentiate this one, you should get this one, whichever situation you have there. This one's easy, of course. Put the formula down, plug things in, integrate ex, which is just ex, and that's it for that one. Example 2, x sine x. This one's very similar, except sine x will actually differentiate to cos x, so that's going to make it slightly different. So again, u is the same, u is x. V dash is sine x, so therefore v is minus cos x. Don't forget, when you differentiate cos x, you get a minus sine x, so that's why that has to be a negative. Plug it in, this one becomes a plus because of that negative, and your uv becomes minus x cos x. The negatives are what mucks this up for people, so be careful of those signs. Integrate cos x, you get sine x. You can check that by differentiating that. You should get your cos x that you started with. And that's it for that one, done deal. Ax plus b, ex. Similar again, u is ax plus b. This one's just got a bit more algebra, it's a linear function there. U dash is just ex again. Plug it all in and you get a nice formula. This one can also be done just simply by splitting the integral up and using the two integrals we've done before. Well, that are easy. This one's easy and we did that one before. You plug the answers in for those and you get the same answer. Done deal. Bob's your uncle again. Right, x squared log x. Now this one's a bit counterintuitive. Which one's going to be u? Some people might choose x squared to be u because when you go u dash you get 2x, which is simpler. But then you go v dash equals log x. How do you integrate log x? That's one we'll be doing later. Not so simple. So choose u to be the log x instead. U equals log x, so u dash is 1 on x. V dash is x squared. Therefore v is x cubed on 3. Plug it all into the formula. Integrate x squared, which is x cubed on 3, so that'll become a 9 on the bottom, and that's it. Bob's your uncle again. Bob's busy today. I should ask if there are any questions from anybody, but of course you guys can't talk back, can you? Right, log x, for this one wonders, well, there's not two functions multiplied together, are there? So how can we use the reverse product rule? Well, it's a bit of a trick that you learn in maths that you can actually use it. You can put a 1 in there, and the 1 is going to be like the v dash. So v dash is 1, your v is going to be x. If u equals log x, u dash is 1 on x. So that when you plug it into the formula, uv is going to be x log x, and the other two will actually cancel just to give you a 1. Integrate 1 and you get x, and there you have your formula. Done deal. And the last one, which is an interesting one, because sine x differentiates to cos x, which differentiates again to minus sine x. So sine and cos are kind of oscillating there, and ex stays the same. So this sort of develops into a loop, and which gives you an equation for I. So let's do it. If u equals ex, u dash is ex, v dash is sine x, then v is minus cos x. Don't forget the minus there when you put that in. You plug all those things in. Your u and your v is minus ex cos x. You get a plus there because of that minus over there, and you get ex cos x dx, which is very similar to the original one, and hasn't really got you anywhere because you've still got an integral you can't do. Luckily, if you go again, this time I'll use capitals for my reverse product rule. It's the same idea exactly. V equals sine x, v dash equals cos x. You plug it in. And what do we find here when we see this is the original integral? So if we do some labeling there, that means I is equal to minus ex cos x plus ex sin x minus I. Make 2i the subject of the equation, solve for it, and that's it. Done deal. Did that make sense, guys? I hope so. Hope you have a great day. See you next time. Bye.